into and out of scientific notation. The reason why we use scientific notation is because we will sometimes have very large numbers. And so scientific notation makes very small decimal numbers or very large thousands, millions, billions numbers easier to work with. You have covered scientific notation in math class before. I know this, but scientific notation is a way of expressing a very large or small number by using a simple number that's multiplied by a power of 10. So the proper format for you is given, and then the example line is on the next side for the correct way to write examples. Okay? On the line, you need to have between the number that goes in front of the times 10 to the whatever. It needs to be between 1 and 10, 1 and 9.9999999. Okay? Notice how in the three examples I have here, they are all, there's 2.00, 3.29, 9.75. It could be 3.2, whatever. It's got to just be less than 10 and greater than 1. Okay? And then you say times 10, and then your exponent is your decimal moves. It tells you a lot about moving that decimal. Okay? So these are all correct examples of scientific notation. Incorrect examples, so you don't want to do this. Maybe say don't do. You don't want to have like 0.29 times 10 to the first. Or you notice how that's less than 1, so it doesn't apply. Or you don't want to have 30.1 times 10 to the negative 2. There again, not incorrect scientific notation because the 30 is greater than 10. Okay? So we have some rules to help us with our writing scientific notation. Let's say that we have a regular number and we need to convert it into scientific notation. Well, we're going to move the decimals so that you end up with a number between 1 and 9.99, 1 and 10. The exponent is equal to how many times you move your decimal. The positive and negative sign on your exponent is what gets confusing, okay? When you have a positive exponent, that means that the number you started with is greater than 1. So it's going to be a big number. It's going to be in the thousands, the hundreds, something like that, even tens. You're moving it left. So another way to think about this is think about, you could say it's a big number. And that's why it has a positive exponent. We're moving the decimal left to get it less than 10. Okay? If it's negative exponent, we're moving our decimal to the right. And the reason is because the number was less than 1, and we have to get it to be above 1. And so that's why we're moving our decimal to the right. So this one is going to be a decimal number. Alright, so positive came from a number that was bigger than 10, and negative comes from a number that was less than 1. It was a decimal. Okay, so let's try an example 2. We're going to put these in scientific notation. So the first one we have is 67,000. So no decimal means we imply that the decimal is all the way to the right. And so I'm going to move my decimal until I have a number between 1 and 10. Okay? Well, I have to move left because if I move right, I'm making it even bigger. So I'm going to go 1, 2, 3, 4 times and stop between the 6 and the 7. So when I stop between the 6 and the 7, I'm going to have 6.7. That is between 1 and 10. So that's all I need to write. I don't really need to write down those zeros right now. Then I have my times 10, and then our exponent. The number is how many times we moved. Well, we moved 1, 2, 3, 4 times. And then we moved to make the number less than 10. So it was a big number to start, and we had to move left. So our exponent is going to be positive. So you could just leave it 4, or you could put a little plus sign if you want to, positive 4. It doesn't matter to me. So we have 6.7 times 10 to the 4th is our scientific notation for that. Next one, we have 0.00000045. We're going to start, we have a decimal point this time, so we have our decimal. We need to get the number, the non-zeros, to be between 1 and 10. If I move left, it's going to make it a smaller, tinier decimal. So I need to move right. I'm going to go 1, 2, 3, 4, 5, 6 times to get between the 4 and the 5. Don't worry about all the other zeros. I'm just going to have 4.5. That's between 1 and 10, so that's okay. Times 10. We said we moved 6 times, so we're going to have a numerical value of 6 on the exponent for the 10. But this time we moved to the right. It was a decimal, and we had to move it to get greater than 1. And so when you move right to get greater than 1, we have to have a negative exponent, because the negative exponent tells us we originally started with a decimal, less than 1 number. Last one, 0.0240. We have our decimal place. I have to move so that the non-zero digits are between 1 and 10. So I'm going to move to the right between the 2 and 4. I'm going to be crazy this time and take off only the left side but not the right side zero. So I'm going to have 2.40. Hey, that's still between 1 and 10, so we're okay. Times 10. I moved twice, so I have 2 times. And it was a decimal, so it was originally less than 1. I had to move it right, so we're going to have a negative 2 exponent. So that's how you go from a decimal or from a regular number into scientific notation. Well, let's go backwards. Let's convert from scientific notation to that regular number. The exponent on the 10 tells you how many times you need to move your decimal. And then remember the positive and negative. The positive exponent means you move your decimal to the right because you have to make it greater than 1. So you're making it, so this says make greater than 1. You need to make it a big number when it has a positive exponent because we have to show how many thousands or how many millions it is. So you have to move right. If it has a negative exponent, you're moving the decimal to the left because you need to make the number less than 1. You need to make it that decimal. Make it a decimal. Okay? So you're making it small when it has the negative exponent. You're making it big when it has the positive exponent. Alright. Let's try. Example 3. We have scientific notation. We're going to change it to be a regular number. So we have 8.2 times 10 to the third for our first. Well, it's a positive exponent, so that tells us if it's positive, we have to move our decimal to the right to make it larger than 10. Okay, and it says I need to move it 3 times. So I'm going to go right, 1, 2, 3. Just like we did on video 1 where we spot filled zeros, we're going to spot fill zeros here too. Okay, so I have 8 and my 2 are left over, and then I have a 0 and a 0. So 8,200. If you want to put a comma, you can, but you don't have to. Next one, 1.5 times 10 to the negative 6. We're moving it 6 times because the exponent is to 6, but it's negative this time. So that means that we've got to move it to the left to make it a decimal number, make it less than 1. So I gotta go, I don't know if I'm gonna root. 1, 2, 3, 4, 5, 6. I'm gonna groove down. Okay, so when I do these, it's always, to me, works better. We're starting from the back. Okay, so I have 15, and I won 5. And then I started between the 1 and the 5, and I moved and I got 6 times. So that's 1, 2, 3, 4, 5, 6. And then I put my decimal. You can leave it like that, as that's perfectly fine. Or when you look at my answer key, it'll probably have that 0. And that's okay too. Next, 2.45 times 10 to the negative 4. Well, it's negative, so we're going to do like we just did. Negative, make it small, move it to the left. Okay? And I have to move it 4 times. So 1, 2, 3, 4. So this time I have 2, 4, 5 at the end. And I started between the 2 and the 4, so that's 1, 2, 3, 4 spots moved. 0.000245. In case you want. Last but not least, 7.50 times 10 to the 8. 8 is positive, moving right, just like we did on the first one. Have to move it 8 times. That's a bunch. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Haha. Okay, so I have 7 in my 5 and my original 0. And so that's 1, 2, 3, 4, 5, 6, 7, 8. I'm going to throw the commas in here just to see how big this number is. Whoa, 750 million. Okay. So that's it. Converting with scientific notation. That's all we got. We're doing the scientific notation assignment next in class.